So let's turn now to analytic epidemiology, or those studies that allow for the assessment of hypotheses or associations between suspected risk factors and health outcomes. Again, we're going to focus on observational studies and review ecologic, prospective, case control, and cross-sectional studies. The distinguishing characteristic between ecologic studies and those other study designs is the unit of observation. In ecological studies, populations or groups of individuals are used as the unit of observation, while in prospective, case control, and cross-sectional studies, the unit of observation are individuals. So before we go into detail on each of these study designs, let's look broadly at some of the characteristics that differentiate the types of studies that we're going to use for our research. So starting with experimental studies, again, these are studies that look at prevention and treatment of diseases. The investigator, again, actively manipulates which groups receive the agent under study. So you may be using some of these studies, and I know some of you are using an experimental study design, a randomized controlled trial, for example, in your studies in this class. Under the realm of observational studies, we have cohort, case control studies, cross-sectional studies, and ecological studies. And let's look at some of these differentiating factors between these study designs. So in a cohort study design, the subjects are defined according to their exposure and they're followed for disease occurrence. And we'll, again, go into detail on all of these in the next few slides. A case control study looks at subjects and defines them as either cases or controls based upon their disease status. And then you look at their exposure histories and compare the two to try to estimate an association between an exposure and the outcome, the disease outcome. Cross-sectional studies examine the relationship between exposure and disease prevalence in a defined population at a single point in time. So here you're collecting both the exposure and the disease outcome at the same time. You're measuring both at the same time. And then ecological study designs examines the relationship between exposures and disease at a population level rather than an individual level. And so those are the designs we're going to talk about first. And again, what differentiates ecological study designs from the other three, cohort, case control, and cross-sectional studies, is the level at which we're looking at the disease, whether it's the population level, and that would be ecological study designs, or the individual level, and those would be the cohort, case control, and cross-sectional study designs. Let's delve first into ecologic studies, where the units of observation are a population rather than an individual. Frequently, the unit of observation is a country or a region or a group of people. And in ecologic studies, the mean values of the hypothesized risk factors and the outcomes are generated for each observation unit. Again, remember that the observation unit is a population rather than an individual. So variables that you'll typically see in ecologic study designs include aggregate measures, and these are measures that summarize the characteristics of individuals within the group as the mean value of a particular parameter of interest or the proportion of the population with a characteristic of interest. So for example, the prevalence of disease across countries, the proportion of smokers in various regions or countries, the median education level, the average fish consumption, average sugar consumption, the average red wine consumption across countries. All of these are aggregate measures that you might derive in your ecologic study design. Environmental measures that you might find in ecologic study design. These are those measures that represent the physical characteristics of the entire group of interest. So for example, hours of sunlight or air pollution. What's the air pollution level on average across the entire country? And then there's global measures. These are measures that look at the characteristics of the group that are not analogous to the individual level. So for example, the healthcare system of a country, the regulations, the public health actions of a group or of a country, or health inequalities. So here's an example of a typical ecologic study. In this case, the investigators are examining the relationship between sugar consumption and prostate cancer mortality. Rather than looking at individual level data, that is, individual level information on the consumption of sugar and the risk of cancer mortality, the investigators here are using an ecologic design to assess the association between the two. The graph is a plot of the per capita sugar consumption of each country versus the age-adjusted prostate cancer mortality in each country. And what you can see is clearly a relationship between the aggregate population level sugar consumption and prostate cancer mortality. When reading an ecologic study or considering this design, there are a few strengths and limitations that you should consider. First, on a positive note, these studies are generally quick and inexpensive as they use data that's usually aggregated by others and readily available for your use. They are helpful for generating hypotheses that then can be further investigated using what we would generally consider stronger designs that incorporate individual level data. And in some cases, ecologic studies can actually provide really good information when the goal of the study is to inform or study some population level action. So smoking bans are a good example of this. When we study the effect of smoking bans, using an ecologic design can be useful because the action, the ban itself, was taken at the population level. The major limitation to the ecologic study design, however, is what we call ecologic fallacy. This is the bias that may occur because an association that we observe between variables on an aggregate level, at the population level, does not necessarily represent the association that exists at the individual level. Errors that are associated with ecologic study designs are the result of this cross-level inference that occurs when aggregate data are used to make inferences at an individual level. Let's walk through an example of ecologic fallacy. In this study, the investigator wants to study the relationship between caffeine consumption and hearing loss. The data in the table shows individual level data collected from 3 populations. In population 1, the average, or the aggregate level consumption of caffeine is 256 milligrams, and the prevalence of hearing loss is 50%. In population 2, the average consumption is 243 milligrams, and the prevalence of hearing loss is 40%. And in population 3, the consumption is 226 milligrams, and 30% of the population has hearing loss. If we were to analyze this data as an ecologic study, we would conclude that there's a positive correlation between caffeine consumption and hearing loss. However, if we delve a little deeper into the data and look at the individual level data of concentrations in hearing loss, what you'll see is that the average consumption among those individuals with hearing loss is 166 milligrams, while the average consumption among those without hearing loss is 292 milligrams. So this is an example of ecologic fallacy, where the conclusions at the population level do not hold when you look at the individual level data.